Ilan. Oh, there you are. Ilan Segal is going to present on drone mapping post-disaster for restoring electricity.
Yeah, perfect.
Oh, awesome. I mean, that's what everybody says to me, but okay. Round of applause.
Thank you guys. My name is Ilan Segal. I haven't presented on this stuff before, so bear with me. I went to University of Maryland, so I'm a Terp. I did the GIS program, studied with Dr. DeVaya there, and then started working with Duke Energy. It's the utility company for the southeast US area and Indiana. And something about the southeast is it gets hit by a lot of hurricanes. So we kind of go into crazy mode during hurricane season, and usually I work in the high-powered lines department, helping out with any mapping issues and GIS tasks in general. It's the lines that go from the power plants to kind of the midway points. So it's the high-powered utility lines, mainly like out of cities that are 500 kilovolt to 16 kilovolt lines. And basically we make sure that the trees don't fall onto them and create power outages for a whole subregion, and make sure the poles are intact and everything. So when hurricanes come, I get a call the day before that, you know, there's a Category 4 coming to North Carolina, South Carolina for Hurricane Florence or Hurricane Irma. I've worked 4 hurricanes so far in the last 4 years, and this presentation specifically will be about Hurricane Michael that hit the Panhandle of Florida area where I'm from. So I work for a company named Theorem Geo Associates. We're just a consulting firm that works with Duke Energy. Next slide. So in general, what happens during a hurricane? The hurricane rolls through an area, and then once the wind and rain subsides, then we're able to finally go in and see what the heck happened. There's outages all across a region. In this circumstance, it was all over the Panhandle of Florida. So do you know where your outages are? Do you know what entire lines are down? The whole Panama City area was completely black during that time frame. So once the wind and the rain subsides, then you can start sending helicopters out and surveying the damage that was caused out there. The people back at the central command that has the whole map on the screen, it's true with all the lines, and it tells them which one's out. That only tells them which large 40-mile lines are out. It doesn't tell them which pole fell over because of the winds and caused the entire line to come out. And we need to go in with crews to fix those specific poles to get that line back in power. So we fly the entire 20,000 miles of transmission lines for an area, and drop down, find the damage, and then once all of that surveying has been done, then we send it to Central Command. They send line and tree crews out, lineman crews, tree crews out to those locations and fix the problems. For then that situation, we send out now UAVs with those crews to support and have more aerial views, make the operation safer, get more detailed reports of what's actually out there so that they can operate safely. You can go to the next slide. So the first stage of it with the helicopter surveying, I've been working in the aviation department. We have 4 aircraft for the last 5 years, and I support us on a normal day-to-day basis, but hurricane aerial operations is a completely different thing. We have 4 of our pilots that go out and support the surveying, But for Hurricane Florence, that was hit the entire North Carolina and South Carolina entire area as a Hurricane 5. It started out as on the border of 4 and 5. We brought in 20 other helicopters from across the country, Montana, California, just random people that were able to come in and support. They take a random person and start flying around, and all those areas are very new to the people that are flying those and to the people that are in the helicopter, actually, that know the lines and can report what the damage is. And it's a very dangerous environment. It's the most dangerous aerial environment, non-military, in North America, is the wire environment, where you're flying around transmission lines that are 100 feet tall. You're flying 80, 100 miles per hour at 110, 120 feet. So you're just a couple, 20, 50 feet above the utility lines. And lines are very difficult to see. And the highest rate of accidents for helicopters in North America are wire strikes that just rip through the entire aircraft. So it's spatial awareness in any means is very important for this. So you can go to the next slide. Go to the next one, actually. So I started having the pilots just using an Explorer app. Duke Energy has uses Esri in general, among other systems. And so the pilots are using Explorer. This is just a random Google image of Explorer. And they have their iPad, and it shows, I put all of the utility lines on there, the structures labeled so they know exactly where they're flying. They have more of a situational awareness as they're maneuvering around that dangerous environment. And with this Explorer app, right before the Hurricane Michael hit, I found out that you could also drop kind of markup points, kind of superficial points that isn't tied to any feature service in the back end, but you can upload it to a service, and then GIS techs on the back end can kind of connect all the dots. And so I trained the passengers going into these helicopters to drop points at all these locations whenever they find damage. Previously, you can go back one slide. Previously, what they've been doing for all the hurricanes in the last decades, they've been flying and writing down on pen and paper, structure 100 has a tree down on this line. Structure 251 has this pole is bent in half. And then at the end of the day, they have to go in after 6 hours of flying for 2 days, which is grueling. They put it into a spreadsheet. This is an example of the spreadsheet and the structure that they're next to, and then they send it to Central Command, and then crews are sent out to those locations. With Hurricane Irma, how it happened in Florida is my coworker put it on pen and paper, wrote it in a spreadsheet that night, didn't have Wi-Fi at his location, so he had to take a picture of the spreadsheet, send it to Central Command. Central Command then didn't have Wi-Fi when they were trying to send it out to the cruiser. They didn't have it, so they had to take another picture, send it to the crews that are in the disaster relief area with bad cell coverage and everything. So it was this, half day, full day type of event, where now using Explorer, you can go 2 slides. We were able to, right when they landed, the passengers uploaded the damage assessment, and in the web app that I built, I was sitting next to the lead for Central Command. I was able to show him exactly where all of the damage was for the whole Florida region that was hit. And this was also sent out to all the crew individuals that had the Explorer map as well, and they were able to navigate safely to those locations and start doing the work to a very streamlined process. You can go to the next slide. So also, not many people know, but Hurricane Michael went through the Panhandle and then also hit North Carolina. This is a northern North Carolina area, South Carolina, and we have territory up there. It was right where Hurricane Florence hit as well, 2 weeks before, and I was working 6 to 9 for a week now for that one as well. And so it hit a lot of the poles that were already damaged from the hurricane previously. So I had people up there surveying all of the damage and putting down all of those points. And it turned a half-day process into a 5-minute process. This is just an example, before I go to the next slide, of temporary flight restriction that was given to us. The Coast Guard and FEMA were operating in this area during Hurricane Florence, and so we had to get the shapefile and put it up into this map so that the helicopter pilots knew not to fly in that region, and also the UAV pilots knew not to fly in that region. Go to the next slide. So at the same time, my main job for this was to manage all of these new UAV crews that were coming in to support all of these crews that were going out there. And I have no idea, I'm probably over 5 minutes, so I'll keep it short. But for the 2 hurricanes, I was managing a total of 35 UAV crews, 2-person crews, and they all had 2 to 4 drones with them. Each were $30,000 plus a 30 times optical zoom, so they could fly a mile and then see another mile with clear accuracy. So you can see if that insulator on that pole has a crack, and then they can tell the crew, bring the equipment to fix that specific problem. I don't know the line inside too well. But that's an example of one vendor that was flying Hazon Solutions with a M600 8-rotor, or M6, checking a substation, surveying that area. This was in a swamp, actually right next to Disney. Different drone, different crew. They rode out on this amphibious vehicle from the land into the water, and it was chugging through this swamp. You can go over logs, and there's gators on the sides, and the transmission line is up at the top there. And he took off, the pilot took off from the top of that amphibious vehicle and surveyed the area. So it gives eyes to a lot of crews that don't have that normal support. You can go to the next slide. I'm probably over, but just real quick, the next 4 slides are, I was sitting in Central Command, and in our industry, we're pretty new. It's a booming new field, and the public sector has done an incredible job on it. But in the private sector, in the industries, it's still trying to be pushed through, and more people are realizing the benefits of this. And so there's just low-hanging fruit type stuff that is so easy. I was sitting in Central Command, and they were sending out, like the past 10 hurricanes that they've done, sending out reports to FEMA, to mayors of cities, to state government organizations, Coast Guard, saying the status of where Duke Energy is with the power restoration, when Panama City can get their power back, basically. And they were sending just a report of, like, typed out, these lines were out, or 70% of this area is out, or something. So in like 10 minutes, they told me the lines that were out and the substations that were out. I made simple maps, and so I'll go through these 4 maps. I made one every day that just basically showed the outages. So this one is the first day, this one's the second day, this one's the third day, less outages, this one's the 4th day, barely any outages. So just low-hanging fruit type stuff that made everything a lot easier. You can go to the next slide. Thank you guys for listening. Ilan Segal, Theorem Geo. We can talk
Some awesome stuff. We all like our electricity, so it's really good when the power comes back on after a disaster. So thank you, Ilan.